Hi everyone, welcome to our team project presentation. Here are our team members: Vivek from Economics, Chimyang and Roshan from Civil, and myself Rutvik from Electrical Engineering Department. For our project, we decided to solve some household problem using the knowledge we learned in the past few classes. So we decided to take the case of the cylinder. That is, we decided to monitor the gas cylinder continuously and display the amount of gas present inside the cylinder. By enhancing this project, that is by using IoT, in the future you can automatically book a gas cylinder instead of manually doing it every time. For our project, we decided that we will use a load cell because the ultrasonic sensor had a lot of issues. Like, if you wanted to use the ultrasonic sensor, you had to place it inside the cylinder, which is practically impossible and pretty dangerous. And if you put the ultrasonic sensor under the cylinder, the waves which will reach the layer of the gas, it may not come back with the whole energy because a lot of energy may be lost in crossing the body of the cylinder. Now I will explain about the coding part which is required for our project. Our project requires two codes, both of which are pretty simple thanks to the HX711_ADC library which was available in the internet. If that library wasn't available, then we had to create an objects and define some parameters inside it such as the .begin and .start1 here. Now I'll explain the first code, which is not the actual code which we'll be using for the project, but it will help in creating it. So basically, this first code, it is mainly created due to the calculation of the calibration factor, which is given here. Initially, we'll set the calibration factor as 1, but according to the values displayed in the serial monitor, we'll change the calibration factor accordingly, so that our weight displayed is the correct one. You'll get more clarity about the calibration factor in the later part of our video. So I'll explain this code right now. We have included an HX711_ library here. This is the library of the amplifier which we're using. We are using an amplifier since the load cell increases its output in millivolts and Arduino can't measure it. So this amplifier amplifies the voltage of the load cell and gives it to the Arduino. So here we have introduced load cell 4,5, which means that we are connecting the DT pin of amplifier to pin number 4 and SCK pin of amplifier to pin number 5. Now what are DT and SCK pins? Basically, DT pin, it stores the value which it receives from the load cell, and SCK pin, it transfers this value which is stored in the DT cell to the Arduino. Basically, the output part of the amplifier has 4 pins: ground, DT, SCK, and the VCC. The ground is obviously the ground port, and VCC, it is the power input port. Now, this is the code part which I have written here. Initially, the calibration factor is 1, but we'll change it. I want the output to be printed on the serial monitor. So I've introduced this serial monitor, which it was already an inbuilt function of the Arduino IDE. I didn't have to install any additional library for it. And I've created a variable I, which takes in float values, and it takes the values of the load cell. That is, it has the function load cell.getData. That is, it measures the value of the load cell. And I want to print that value in the serial monitor, so I've used the function serial.println I.
The code for finding calibration factor. Now I will compile it, and compilation is done. Now I will upload it to Arduino. Then it is uploaded. Now I will show the values in. I have put nothing on a load cell. You can see here values are just vibrating between 1, 2, 1, 3, 4 or minus 1, 2, 3, 4. Now I will keep 1 kg weight on it, and let's see here. I kept 1 kg weight on load cell, and it is showing around 1021 gram or approx. So it is approximate. Now I kept 2 kg weight, and it is showing around 2224 grams. So it is.
Now I'll explain about the second part of the code too, which is the actual one. We will be using this one for a project. This is pretty similar to the first one and pretty simple because of the HX711_ADC library which was present on the internet. Here, in this code, we have set the calibration factor to 11.2, which we have calculated previously after doing so many trials. The only thing different is I have introduced another variable, that is the float L variable, which takes in float values as this function. Here is the value of the load which I measured the load cell in grams. So this L variable will give you the value of the amount of percentage of the gas left in the cylinder. and I want to see the value in the serial monitor. So I've used the code serial.println and I'm trying to compile it, and it has no errors. Now I'll explain how I've introduced the float L variable in the second code. That is, I'll explain how I've calculated the percentage of gas left in the cylinder. We found out that the total weight of cylinder is approximately 31.2 kg, where 17 kg is the body weight and 14.2 is the gas weight. As I've already mentioned, I is the weight of the load, which is measured by the load cell in grams. So at any point of time, I is equal to the body weight plus weight of the gas left in the cylinder. So the weight of the gas left in the cylinder would be I minus 17,000 grams. So for the percentage of gas left, I have to use the formula amount of gas left by total amount of gas into 100. That is I minus 17,000 by 14.2 into 10 cube into 100. That is I minus 17,000 into 0.007042. This function I have introduced as float L variable, and I'll be printing it in the serial monitor. Now we'll look into the demonstration of our project.
I am here to show you the components required for our project. First of all, here this is Arduino cable for connection to Arduino to PC. This is Arduino. This is load cell, which is, you can see here, this is HX711 amplifier, which is used for load cell measurement. Now these are the connecting pins. These are the amplifier which connect amplifier to Arduino. Connections of Arduino to amplifier. First of all, we have to connect like this, and to Arduino, red is ground, like ground is connected to ground of amplifier. Now DT pin of amplifier is connected to fourth pin of Arduino, and SCK pin of amplifier is connected to fifth pin of Arduino, and 5-volt source of Arduino is connected to VCC of amplifier. Connection of load cell to amplifier. First of all, red is connected to E plus of HX amplifier, and now next one, which is brown, is connected to E minus of amplifier, and white is connected to A minus of amplifier, and last, which is green, is connected to A plus of amplifier. Now we connect Arduino to our PC. Here we place cylinder on load cell, and you can see reading here